So today we will start with the polymorphism topic. It's again one of the main topics in inheritance in Java. So what does this mean? Well, it's a Latin word, so poly means many and morphs means forms. So basically objects that have many forms, that have multiple forms. So why do we use it? Um, Well, we use it to, I'll give you one example. Let's say, I had given this example before, I guess. We have an e-commerce platform, and let's say we are selling many items, and then we would like to implement this basket part, so in which the user is interested in some of the items, so the user adds some items to the basket. Like maybe it's a clothes, some books, some shoes, some computer, whatever it is. But then this is what users see. But from a software developer perspective, what is a basket? Well, probably it's like an array list in which we keep some items in that. But then the problem is, like, when you have a basket, when you have these different items, what should the object type that we should keep in that array list? Because when we define an array list, we need to say, okay, we will keep only one item. Like I can say, is it books, is it clothes, or so. What we do is we keep it as a product array list, because eventually book is a product, or you might say item. Smartwatch is an item. All of them is an item. So I keep them in an item list. So that will be my basket. So this is why we say that we use it as an array type, because this is their common point and I want to keep them in a list. Or sometimes we don't know the exact type, so this is the main common point. We don't know the exact type, like is it a book, is it a cloth, but so for those cases we use this polymorphism. It can be an array type, it can be a method parameter, it can be also a method return type. And polymorphism relies on dynamic proofing. We will see it in the following slides. So I will, in short, for now what we can say is, like, when we compile the data, when we compile our program, the Java knows, okay, this is a book object, this is an, I don't know, the smartwatch object, it knows it. This is called static binding, but in the dynamic binding, it decides during the runtime. Like, okay, I don't know what it will be, what the user will put in a basket. Is it a book? Is it a watch? I don't know it. It will be decided at the runtime. This is called dynamic binding. But this is a very just overview. So now let's go into the details. Okay, so let's say that I want to keep as an array type. Like, let's say that I have this shape class, and I have this rectangle, circle, triangle subclasses. So each of them extends shape class. And then I want to keep them in an array, like the shape array, which has this shape's name. So when I do this, what I will be able to do is, in this shapes array, in one of them, I can put a rectangle. In another one, I can put a circle. In another one, I can put a triangle. The reason is that because of the inheritance they have, I can easily say that, okay, rectangle is a shape, circle is a shape, triangle is also a shape. So all of them is a shape. That's why Java will not make it a problem.
It's the same thing of the dictionary in Python?
I cannot say that. In dictionary, in Python, it's more like an indexing part. It's like I can use index as a string in dictionary in Python. So this is still an array. Still we have the numerical indexes, like index 0, 1, 2. But the thing is, when I write my code, I say that, okay, this is a shape array. So when we read the code, it's a shape array, but I can put it in different objects that has the same inheritance relationship with the shape, like rectangle, the other one will be circle, the other one will be triangle. So I can do all these, I can keep them in the same array list. Like this is, you might think it as my e-commerce basket example also. It's also the same way. Now, since this is all shape objects, and a shape object might have different, all of them has a get area function, but they have different attributes. So we'll talk about these parts, but from a Java perspective, again, we can use it as an array, or what we can do is I can use it as an parameter to have a general idea. Like let's say I want to calculate, define a function, get paint cost, and then it will be based on area. It will take a shape object again. So that's why I use it as a shape. But then when I'm running it, what I can do is I can give it a circle, a rectangle, a triangle. Since each of them again is a shape object, even though I define it shape, when I'm running it, I will be able to call all these functions. So this is also to make it more general. What would happen otherwise? Like I would say get paint cost and rectangle. And then one more function, get paint cost for a circle, get paint cost for a triangle. So for each of these objects, I need to replicate my code. But instead of doing that, I know that, okay, all of them are shape. So I'm putting this shape object, and then Java allows me to put these different objects.
Did you send the recording?
Yes, I did. I will give one more example. This just we are going quickly for now. And then the other one is the return data type. Again, maybe we will create a class that will take a string, and then based on that string, it will create different objects, like maybe rectangle, circle, maybe triangle. So here is the thing. During the compile time, I cannot know what this will be. Is it a rectangle, circle, or triangle? By just reading a code, we cannot understand, because we don't know how it will be used. So that's why when we are saying returning the type, we don't say, okay, triangle data type or circle type data type. We are saying that it is a shape data type, so that it covers all of them. I would like to do one example for this. So now we have seen array type, or a parameter, or a return type. Let me go to my Eclipse part, and then let's do this example. In my e-commerce platform again, sorry, I would go to this. Let's say we have this item part, okay? We have this item object that we are selling, okay? And then we would like, so each item has a name, each item has a flow, the price, and all of them has some calculate the final price function, okay? And then now I would like to create, I don't know which one was extending this, so not this one. I'll just create some more items that will create it, okay? So let's say I will create another item. I don't know, let's say toy for that one. So it will be very general names, I'm aware of that. So I will say, okay, this will extend item. Okay, we are getting an error that says it doesn't have this default constructor that doesn't take any parameter. That's why we were getting that. Okay, I just put it, so now we are not getting it. I would like to put one more, actually two more items. So let's say toy, and then they will be very basic names, like the food, and then maybe we are also selling foods on the same part, so it's then also an item. And I would like to put one more, which is, I don't know, you name it. Water. All right. So yeah, that's fine. And we are saying water. So this is part. and it should also extend this item. And then what we will have is, let's say that for each of them, we have, I'll go back to my product part. So we have this calculate final price function, okay? Eventually it returns 0, but let's say for the items it shouldn't be 0. I will say that, okay, no, it shouldn't be 0. It should be including text or so. The content is not that important for now, okay? But say that, okay, we are selling it for 10. All right, and for the food item, again, now we are selling it for 20, or yeah, 20. And for the water, we'll say, okay, it's 1, let's say. Maybe cheaper, I don't know. Now I'm going back to, so now we have 3 items, food, water, and toy. Each of them are extending item. And then I'll go to my, let's create one more class for our e-commerce platform, okay? It will have a main function. Now I'm implementing this, in which I need a basket for the user that he will put the items that he would like to check out, okay, buy. So for that one, I will say, okay, I can say array list. I'll talk about the data type later on. And then here is my array list. But now, what should be the array list type? What I could do is I could create separate array lists for water, for food, for what was it, toy. But then, well, I'll end up so many array lists. That wouldn't make sense. Like, I will have different baskets actually. So what I would like to do is, well, I'll say, instead of doing it, I will say, okay, I have an item basket, okay? I need to import it. That's why I should be getting this error. Yeah. So now what I will be able to do is, if I have a toy object, toy t is equal to new toy. Let's say that we would like to buy a toy. We would like to buy some food item. And we would like to buy some water. Then I would like to add all these items to my basket, okay? So now this will allow me to do it. I will be able to add my toy. I will just do a copy paste here. I will be able to add my function. I will be able to add my water. So Java didn't complain about it. In the compile time, it didn't complain about it because, well, basically it's saying, okay, you are adding toy, and toy is an item. So, all right. So this is a basket that keeps items. So it's an item. It has an is a relationship with the item. So you can add it. So now the question is, when I come to, let's say that, okay, I would like to check out. So I need to calculate the total price. So I need to go over my list. Sorry for this part. So I will go over all my list. So now, how will I write it? I will go over my list. It's an item array list, but I know that it has 3 different items in that. But I know that all of them is an item. So I will go from the item part, and then I will say basket. And then at each item, I will basically say, okay, since all of them has this calculate final price, I will call it. So it will give me I will be able to calculate my total price. And then I will just print it, like the total price is whatever, this one. So now the question here is, now let's look at it from a compile time, okay? We don't know, so this part, the user will select whatever they want to buy. He might buy a toy or not, it changes. So the content of the basket will change always. But when we are reading a code, okay, this is the checkout part. I am calculating the total price. How will I calculate it? Okay, this is an item list. Also, this is an item object. And I need to go to the calculate final price. So I'm going to that calculate that code, and it says return 0. So then, all right, what is my total price? Is it 0 because this is an item object from a compile time?
No. It's overridden. Overridden in each.
It's overridden, but I'm not. But this is an item object. So I don't know from in the runtime. This is what we will see. We will not see what is added. Like, okay, now you can say that, okay, we added basket, this toy, food, water, but maybe the user will not buy any food. So we don't know actually the items there. It's in the compile time. So it's just item object, and then I need to calculate the final price. So it suggests that, yeah, it might be 0. And when I run this, but it says, okay, it's 31. So what is happening here is, sorry, this is called dynamic binding. Why? So Java does not allow us, Java does not cause any this kind of a miscalculation. But how is this happening from a technical perspective? It's because of dynamic binding. What is that? Well, first, if it was static binding, it means that in a compile time, Java will decide, okay, at this point, I will call this function, which is calculate final price of item. So in a static binding, we define it at the compile time, what should be done. But in a dynamic binding, what Java does here is, okay, I will decide it at the runtime because I don't know in this item object, is that a food item, is that a water item, is that a toy item, I don't know it. So at the runtime, when it needs to calculate the total price, it will check, okay, it looks like an item, but actually it's a food item, so let's call its overridden version of it. So this is called dynamic binding. And I'll go back to here. And this is also polymorphism. Polymorphism, what does it mean? Poly means many, morphism, form. So it has many forms. Why is that? Well, when I'm looking at this looks like an item. But when I run the code in the meantime, well, it runs like a book object. It runs like an water object. It runs like an toy object. So it has multiple forms. That's why we call that it is polymorphism. Many forms, object with many forms. Do you have any questions so far? Well, if you understood this part, you understood 90% of what polymorphism is. The others are just some other little details. Now I'll go back to my slides again. Here just some more examples just to to better understand, okay? Let's say that we have this animal class. Again, we have attributes, methods, which has this talk method. And then we have this dog and cat. And then we have a bulldog, which also extends a dog class. So each of them, let's say that overrides this talk class, talk method, because each animal has a different voice, of course. Now, as you can see, and this is the implementation of it. We have an animal, and we have this animal sound method. That of course, we are not actually making a sound for this dummy toy. We are just printing a message. So it has this animal sound method, and then we have these cat and dogs methods. And then, so they override it. And then what we can do, this is just another way of writing it. I can create one animal object. Animal, my animal, new my animal, new animal. So this is not a polymorphic object. This is just pure animal object that doesn't have multiple forms. But when I say animal, my cat is equal to new cat, Java will allow that. Java will say, okay, cat is an animal, so that will be valid. All dogs is also an animal, so that will be valid. This is also what we had done in the when we are adding items to the basket, or we can also think it in this way. I'm creating, and this will be a polymorphic object. It has multiple forms. It looks like an animal, but at the runtime I put a cat object in it. It looks like an animal, but I put a dog object in that. And then when we run it, this will run. Each of them will run the animal sound function that we defined for them. Yes, please.
What's the difference between putting animal class and cat class?
That's a good question. Now this becomes an animal object. This becomes a cat object in the runtime. But this is not a fully cat object. This is a full animal object. It runs only. I will actually give it one example for this in my code. Let me also show this from this example here. In my code, I could also say item I is equal to new, what was it, toy. So now this is possible. Now this becomes a polymorphic object. It means that it's not a fully item object. It's not a fully toy object. What does it mean? I will explain this. But when I do this, actually I'm also doing the same thing here. I'm adding though, I need to add an item object, but I'm adding a toy object here. I need to define an item object, but I'm putting a toy object. This is the main idea.
Above we didn't say like item in the new toy. We said toy new toy.
Well, I could say this, if you would like to put it in this way. Normally this should take an item object, but I'm putting a new toy object. These are, these will basically just a different way of defining polymorphic objects. But what is the difference between a toy object that is, okay, let me. So what is the difference between this? I'll give the name T1 and T2. So one of them is T1 and the other one is T2. I say item T1, the other one is toy 2. And I both say that they are new toy. What is the difference? Well, for that one, to show that I need to add one more function. Let's say for a toy function, I'm overloading. Okay, I will put one more function that doesn't exist in item. Let's say, I don't know, what can it be? For a toy object, something specific. Well, maybe it is like get color, okay? Maybe it has this kind of a attribute for the color object. Okay, and it will just return this. All right. Now I'm going back to my e-commerce platform. Now what I will do is, let's say I would like to, I can get color. For the T2 object, for this non-polyformic full toy object, I can call this get color object, and I'm not getting an error. But what about T1? I'm getting an error. Okay, it's not working that way. So then what is the rule here? What is happening? Why I'm not able to call for T1 but I'm able to call for T2? So here is the thing. When Java is compiling, okay, it's still considered that it's an item object. And then what are the functions of an item object? It goes to here. It says that, okay, it has this calculate final price object function. So it can run it. Because it's an item object, that's why if you would like to run it for T1, it can run this calculate final price object, because it will say it is an item object. Sorry. Yeah. But when I'm trying to run this, it will say, okay, in the runtime it is deciding that. In the runtime, from Java's perspective, it's still an item object. It's okay, and then say, okay, item does not have get color, so you cannot run it. This is what it's saying. And for the T2, yeah, it's a toy object and it has this get color function. You can run it. And then when we are running it, but this is the polymorphism part. When T2 is running this calculate final price, it will say, it will not now go to the item object, but it will go to the, for the T1 object, it allows me to run it, but it runs when it needs to run. It goes to the toy object and runs its overridden version. Is that understood? So this part, like 99% of polymorphism knowledge. That's I can say this if this part is understood. So a polymorphism object, basically, I'm just now recapping it. It's not a fully item object here. Why is that? Because when I run this function, it doesn't go to the implementation in item object. It goes to the toy object because I put here a toy object. So it's not a fully item object. It's partially. What I mean is that, then you can say, is it a toy object? Not exactly, because I'm not able to call the functions that is not defined in toy object. I can only call the functions that is defined in item object. So it's not a fully toy object. It's not a fully item object. It is a polymorphic object. It has multiple forms. Is that understood?
This is only used in loops, right?
It's loops. Well, in array types, yes, we can use it to. I'll go back to here now. Yeah, we can use it to keep similar items in one array, and then we can use this parent class as the array type. So this is one usage. It can be used for the parameter ways, like I would like to calculate the get paint cost for different objects, and each of them, it will be based on array function. So instead of replicating for each of them, like get paint cost for rectangle, get paint cost for circle, I'm just putting this shape function. And then since all of them has this get area function, which is probably overridden based on rectangle, based on circle, it will give me still correct answer. So I can also do it in this way. Or maybe as a return type, if I don't know which object needs to be returned, like is it a triangle, circle, rectangle, is it a toy, water, food? So what I'm doing is my return type, I put the parent class there, and then it returns this object. The return ones will be again a polymorphic object, because from a Java perspective, it needs to be shape, but we are putting there a rectangle or a triangle or a circle. All right, shall I proceed?
What is the name of the returned objects? Like there is no name for the return. Like how we can access them? Returned object by the
return object.
return, like this function returns a new object. How we can deal with that afterwards when you call the method itself?
So I need to make an assignment here. Then I can, through that variable, I can use it. All right. I think let's give 1 minute break for attendance, and then we'll continue.